Okay, so let's start with some section 4.1 stuff. So this was extreme value theorem, finding mins and maxes of functions. So let's find the absolute extrema of the function 12x to the 1/3 minus x on the interval -1 to 27. Okay, so how do we go about solving this problem? All right, let's see. Finding the derivative of f of x and locate where it does not exist and it equals 0. Good. So in other words, we're finding the critical numbers. Okay, so we get one type, which is where f prime of x does not exist. So can anyone say where the derivative does not exist for this function? Is this function is continuous everywhere, but is it differentiable everywhere? So what about the term 12x to the 1/3? So yeah, you're right that that is kind of a problem term. Why does that term kind of um, you know, scream out at you? Something about non-differentiability. What's so special about this first term? So it has a fraction exponent. So it's not necessarily that it's a fraction exponent. It's that the exponent is less than 1, right? I think that's what you actually mean, right? I mean, remember, like 5/4 is a fraction. So what we mean is this exponent is between 0 and 1, so that means it's going to be continuous but not differentiable. And how do I actually find that point of non-differentiability? For you recall, wherever the exponent is, that exponent that's less than 1, you set the base of that exponent equal to 0. Now, if you don't remember that part, now that is in the optional, well, it's actually not optional notes, it's in the extra notes for section 4.1, a catalog of non-differentiable functions. But just in case you don't remember that, let's actually compute this derivative. So if I compute this derivative, we get 4x to the -2/3 minus 1. And I'm actually going to write that negative exponent as a fraction. So I can write this derivative as 4 over x to the 2/3 minus 1. So we can actually see explicitly in this derivative that we have this denominator. If x equals 0, I'd be dividing by 0 here. So x equals 0 gives me derivative does not exist. Okay, so now let's also look at the stationary values. So where is the derivative equal to 0? So this is just some algebra we have to do. So 4x to the 2/3 minus 1 equals 0. So we get x to the 2/3 has to equal 4. And what are the solutions to this equation? Now be very careful, right? Why do I have to be careful? That 2. So the 2/3, remember, really means I'm squaring something. And whenever you're squaring something, you have to be careful that you actually get all of the correct solutions. So for instance, you should really think of this as x to the 1/3 squared equals 4. So when I take a square root to undo the square, I actually get two possible solutions. I get x to the 1/3 equals -2, or x to the 1/3 equals +2, right? Remember, you get both solutions. And then each of these equations we can solve, right? To undo the 1/3 power, I can do the cube root, and not cube root. I can just do the cube, right? Raise both sides to the power 3 to undo the cube root, and so I get x equals -8, or x equals 8. So we get two possible solutions here. And we are going to reject the -8 because that's actually not in the interval. The interval we were interested in was -1 to 27. But it is important that, if that interval will actually did include -8, you would have to include this critical number, right? So make sure you don't miss that. I remember when I gave this on an exam, a lot of students missed the -8 critical number because they didn't solve this correctly, right? They didn't actually do both the negative and the positive square root. Okay, so we have actually now found two critical numbers, right? We found x equals 0 and x equals 8 as our two critical numbers. What is our next step in this problem? So find the y values. Okay, good. So now we make a table of values. Right, I don't need to do a sign chart. I don't need to do second derivative tests. I mean, I can if I wanted to, but since I have a closed interval, if I need to check where the absolute extrema are, I need to check the two endpoints anyway, so I may as well just do a table of values. So we have x values, y values, and the original y was 12x to the 1/3 minus x. And which x values do I have to put on here? I need to put -1 and 27, right? Those are the two endpoints, and then I need to put my two critical numbers, 0 and 8. Okay, so this should be pretty easy arithmetic. So -1 here gives me 12 times -1 minus -1, so that gives me -11. The 27 gives me 12 times 3 minus 27, so we get here 9. 0 just gives me 0 minus 0, which is 0, and the 8 gives me 12 times 2 minus 8, so I get 16 there. Okay, so now we can just say that the maximum is 16 and the minimum is -11. Okay, so now we're all done with that. Any questions about that? How do you know that they're either absolute or local? Well, remember, for absolute minima and maxima, the only places that that can occur are the two critical numbers and the two endpoints in this case. So this is obviously the absolute minimum, -11, because since these are the only four possible values anyway, and it's the smallest of those four values, it's the absolute minimum. If you want to say classify whether 0 and 8 are local maxima or local minima, well, clearly 16 is a local maximum, because if it's the absolute maximum, it's a local maximum. For 0, if you want to check whether it's a local min, a local max, or neither, you would have to do a sign chart, right? You'd actually have to look at the first derivative here. Well, my two critical numbers. My three critical numbers were -8, 0, and 8. And then you have to actually look at a sign chart for f prime and f and see whether you get a local min or local max. But that wasn't part of the problem, so